So welcome to the software testing laboratory program number 2. The program is design and develop a program in a language of your choice to solve the triangle problem defined as accept three integers which are supposed to be the three sides of a triangle and determine if the three values represent an equilateral triangle, isosceles triangle, scalene triangle. They do not form a triangle at all. Assume that the upper limit for the size of any side is 10. Derive test cases for your program based on a boundary value analysis. Execute the test cases and discuss the results. So come to the program number 1, we already explained. So this is also same as program is same as the program number 1, but the condition is assume that the upper limit for the size of any side is 10. So we give the sides in the program number 1, 2, 3, 1, 2 up to 10. So definitely we can give in the program number, so we can give 100, 200, 500, whatever it is to be, there is no problem. But come to the second program, so the upper limit value size is to be 10. So then the sides we give here 1 to 10, the limit is to be there. So same as the program number 1, so here also same, the requirement specifications, design conditions, both are same. That is the come to the requirement conditions. The system should accept three positive integers, that is the R1. So R2 is definitely, if we give the based on the input, should determine the triangle can be formed or not. So we come to the R3, if the triangle is to be formed, so definitely so any one type of the triangle is to be there. That is the equilateral triangle, isosceles triangle, or scalene triangle. So and also one more important is to be the rule number 4. R4 is to be the requirement 4. That is the upper limit for the size of any side is to be 10. So that is the condition of this program. So assume that the upper limit of the size any side is 10. So here the requirement condition upper limit for size of any side is 10. So based on that we can design the conditions. Design condition is to be there. So the design condition is same as the program number 1. So algorithm also is the same as the program number 1. We already explained, but in the program, in this algorithm, we can specify that the upper limit is to be 10 is to be there. So if more than the upper limit is to be, then definitely it shows that out of range is to be there here. So program code, see here. So we can design, this is the if condition a less than b plus b and b less than a plus c and c less than a plus b. So before that we create that one if condition, that is the upper limit is to be 10. If a greater than 10 or b greater than 10 or c greater than 10, and also one more condition is to be there. So if we entered here, we not entered here, that is that if we entered the 0 values to the a, b, c, so definitely it's to be a positive integer. We mentioned that already that. So if we greater than print out, so we can display the out of range values, because we can define that in the question the upper limit value is to be 10. That means that 1 to 10. So we can give the values of integers a, b, c. So with out of range 11, 12, 13, definitely it shows that the out of range values. So after that definitely we give the condition, if condition is to be old, so definitely same as the first program. If three sides are equal, is an equilateral triangle. Else not a equal sides, so it's a scalene triangle. Else definitely two sides are equal, is an isosceles triangle. Same as the first one. So here they told that in the question that, so assume that upper limit of any sides of is 10. Derive test cases for your program based on boundary value analysis. So based on boundary value analysis, so technique used here, boundary value analysis. So definitely for a boundary value analysis BVA problem, the test cases can be generated depends on the output and the constraints on the output. Here we least worried on the constraints on input domain. The triangle problem takes three sides as input and checks it for a validity. Hence n equals 3 means definitely, hence n equals 3 means, so we give the three inputs A, B, C, that is the n value, three inputs are there, that's why we consider n equals 3. Since boundary value analysis BVA yields the formula of 4n plus 1 test cases according to single fault assumption theory, hence we can say that the total number of test cases will be 4n plus 1. So in the 4 in the place of n equals 3 plus 1, so total 12 plus 1 means 13 test cases will be generated in this program. The maximum limit of each sides ABC of the triangle is 10 units according to the requirement R4. So ABC lies between, so 0 less than equal to A less than equal to 10, same as the B also, C also. So equivalence classes for A, value is less than 1, value is in the range, value is greater than 10. We can consider all these three for the test cases. So same equivalence classes for B, so value is less than 1, value is in the range, value is greater than 1, and also C also same as the AB. So from the above equivalence classes can derive the following test cases using the boundary value analysis approach. So totally the 4n plus 1 means 13 is to be there, 13 number of test cases will be generated here. So minimum number of test cases here 13. So more than this you can use 13, 14, 15, 16 up to 20 whatever it is to be. But minimum number of test cases for this boundary value analysis is, so according to the formula we can, minimum number is to be 13 here. So we can generate here, we have generated 16 test cases, is more than 13 is to be there. So for the test case, same as this is the test case format is test case ID, test case description, input ABC, expected, actual output and the status. So you already know that the actual output and the status column is to be empty. So after executing the program you can fill, so based on that expected output. So the first test case is to be for A input is not given, so 2 B input is not given, so test case 3 C input is not given. Definitely if the sides are not given means definitely is not a triangle, so this is the expected output. So come to the test case 4, input C is in negative values, we give the negative values is less than 0, is less than 1 or less than 0. So definitely here to A, B is to be equilateral, equal sides, but in the C the condition is to be not hold, that is the if condition, A less than B plus B, B less than A plus C and C less than A plus B, the condition is not hold, that's why it is not a triangle. The two sides are equal, definitely is isosceles. All sides are equal is an equilateral. So we can that 559 equilateral isosceles. So totally whatever you want to give that, so the total number of minimum test cases for boundary value analysis for the triangle program is to be 13. So after that we can generate many test cases, is left to you. So but minimum number of test cases is to be 13 here. So after executing the program we can write the actual output, what do we get after execution that. So compared to the expected output and the actual output after executions, we can fill the status is to be definitely, so test cases will be passed for all the test cases. So after that we write that, so test reports, number of test cases executed, totally we can execute 16 cases, number of defects raised if any, number of test cases passed, definitely almost 16 test cases will be passed here. So if any cases will be failed, so number of test cases failed we can enter here. So these are the sample snapshots for the triangle program, is same as the for program number 1. So you can enter triangle equal to 3 sides of triangles 559 definitely isosceles, sides of a triangle 551 isosceles triangle, 555 is an equilateral triangle. So you can give the not a triangle also. So this is the program number 2. So upper limit is to be 10. So based on the boundary value analysis. So for the boundary value analysis, very important part is to be the formula number of test cases, that is the 4n plus 1 for the triangle program. The number of test cases for the boundary value analysis is to be 13. Minimum number of test cases will be 13. Thank you.